Okay, welcome back, VHDL. Today we are going to look at listing 3.4. And listing 3.4, what it does is it again looks at your decoder circuit, which I have over here. And I think in listing 3.2 we did this decoder circuit using a conditional signal assignment statement. Well, now we're going to use a select signal assignment statement. So we're going to implement the same thing, but we're just going to use a different construct, the selected signal assignment statement. But to review, on a 2 to 4 decoder, it has an enable pin. And since there's no bubble there, that means it gets enabled when it's 1. Okay, so you notice up here when enable is 0, the device is disabled and all your outputs are 0 because this is an active high decoder. If it was an active low decoder, all these guys would be 1. Well, once enable is 1, this enable pin is enabled, then this chip is enabled. Once the chip is enabled, it responds to those two pins down here, A1, A0. And when A1, A0 is equal to 0, 0, we assert the Y0 pin. Since this is active high, Y0 will take on a value of 1. Okay. If A1 and A0 take on a value of 0, 1, then I'll assert the, actually that was the Y0 pin, I'll assert the Y1 pin. So Y1 will go from a logic 0 to logic 1. When A1, A0 is equal to 1, 0, it corresponds to 2, and the Y2 pin will be asserted down here. And then when A1, A0 is equal to 1, 1, the Y3 pin will be asserted down here. All right, so that's the 2 to 4 decoder, and you can have a 2 to 4 decoder, a 3 to 8 decoder, 4 to 16 decoder, 5 to 32 decoder, all kinds of decoders. And they could be active high or active low. Since I don't have the bubbles here, it's active high. It means everything's low, and whatever I put down on the control, that gets asserted to high. If I have the bubbles there, it's active low. Active high outputs the min-terms, M0, 1, 2, and 3. Active low outputs the complements of the min-terms, M0 prime, M1 prime, M2 prime, M3 prime, etc. All right, well, let's come along here and actually do this. We'll implement a 2 to 4 decoder using a selected signal assignment statement. So let's go back to here. Okay, we've got the project navigator up. Let's close everything. File, close project, and what we'll do is we'll create a new project. And let's see, I want to probably browse to, let's see, I want to go down to chapter 3, right? Let's go to chapter 3. And what we'll do is we will call this guy listing underscore 3-04. Okay. And I've got my Spartan 3E. I've got the device XC3S500E. Notice there's a bunch of devices you can have on the Spartan 3E. That's the one we're using. Flat grid, 320 pins around the perimeter. The flat grid is the Chipkin manufacturing type. VHDL as opposed to Verilog. Okay. Next, finish, and now we have an empty project. Well, the first thing I need to do is put a VHDL file in here. All right, so I select my project, new source, VHDL module. Let's call this guy decoder underscore 2 to 4, decoder underscore 2 underscore 4. It is a VHDL module. Click next. Now, what kind of inputs and outputs do I have on this guy? Well, let's actually go back to our PDF. Yeah, notice I've got a 1-bit input. I've got a 1-bit input enable. I've got a 2-bit input control, and then I've got 4 bits coming out, labeled 0 to 3 or 3 down to 0. Okay. Well, let's use this little wizard here to do that. Let's put the A in there. That's my control. It is an input. It's 2 bits, and it's 1 down to 0. Okay, A1, A0. Then I've got an enable pin. Okay, that's just one line, so I don't need to select bus, turn off bus. It's an input. And then I have Y, my output. Okay, so I need to change the direction or the mode to out, and it goes most significant bit 3 down to 0. Okay, because it's a 4-bit output. So I can click next. Gives me a little information. Double check what I did. And now it stubs out a VHDL module. And as we said in the course many times, there's 3 parts to this guy. And we're not going to use numeric standards, so let's get rid of that. And there you go. There is your as simple as you can get stubbed out VHDL file. There's your library, IEEE. IEEE uses the standard logic 1164 package, which allows me to declare things to be a standard logic vector or standard logic. And then it brings in all the type, actually, that we're using, standard logic vector, standard logic, as well as all kinds of operations and operators on that particular data type. Here is my entity block. We said entity, it basically describes what goes in, what comes out. A goes in, 2-bit control signal, so it's a standard logic vector. Enable goes in, 1-bit standard logic, enables or disables the device, and Y is the output. It's a 4-bit quantity, standard logic vector. So there's your input, there's your output. Okay. Now what we actually have to do is implement this guy. Well, in listing what 3.2, yeah, this is 3, 4, and 3_2. I think we did it with a conditional signal assignment statement. So what I want to do here is use a selected signal assignment statement. They're basically the same thing. You know, it's just a preference on what you want to use. And the way this guy works is you have a with statement. You have a variable. We'll call it S. And then you have the select keyword. Notice with and select are blue. Okay. And then I come down to here and I can set my output, and I could say Y is equal to all zeros, because Y is a 4-bit quantity. When, let's see, when, well, now you got to figure out what do you want to do. When do you want to set Y to 0? Well, you want to set Y to 0 when the enable is 0. Okay, you can disable it, but then you also want to change it when A. So this device here kind of has it's a function of 2 variables. So what might be good here is to use an internal signal called S, standard logic vector, and let's make that guy 2 down to 0. Okay. So it's a 3-bit quantity. And then what can I do here? Well, what I can do here is I can say S takes on the value of enable concatenated with A. All right, let's make a little comment statement here. This operator right here means concatenation. Right? So what I'm going to do here, yeah, I kind of already did that with you. I am going to take the enable bit, which is 1 bit, and I'm going to concatenate it with the control bit, which is 2 bits, and I'm going to create a 3-bit quantity called S. And that's what I'm going to use down here in my selected statement. So whenever S is equal to 0, 0, 0, or, okay, that's or, 0, 0, 1, or 0, 1, 0, or 0, 1, 1, okay, then I am going to output a Y0, because what's happening here is the enable bit is the most significant bit of this new internal variable S, and as long as that enable bit is 0, the device doesn't do anything. It outputs a logic 0, or on all the Y outputs. Okay. Well, and then on the next case, what we want here is to assert Y0. Well, when does that happen? That happens whenever the device is enabled, and then A is equal to 0. Okay, let me do a comma, and then I can pretty much copy this line. Let's copy and paste this line. And let's see, I can assert the Y1 pin whenever my control input is 0, 1. And I can assert the Y2 pin whenever the control input is a 1, 0 and the device is enabled. And then here I can assert Y3 when I get any other values. Okay, and ideally that would correspond to S equal to 1, 1. Right, so that's a little comment statement there. It's in green. And I think at that point we're pretty much done. We've used a selected signal assignment statement to implement a 2 to 1 or 2 to 4 active high decoder. So let's select the project, make sure we're in simulation mode so we can take it all the way through, and then behavior check syntax. Look down here, make sure you've got console selected, and it compiled successfully. Great. Okay, so we just implemented a 2 to 4 active high decoder, and we used the select signal assignment statement. At that point I'm going to stop, and in part 2 we will do a test bench file to make sure this thing actually works.